Okay, so here's another example of solving a circuit using superposition. And in this example, we have two sinusoidal voltage sources. Now, if you see a circuit with two sinusoidal voltage sources, and those voltage sources have different frequencies, then you are being forced to use superposition. And this is the main reason that you would use superposition in the first place, is if you were trying to solve a circuit that has two sinusoidal functions with different frequencies. So after we've solved this circuit, we would get something that looks we would get an answer that looks something like this, with V prime cosine WT plus an angle plus V double prime cosine W double prime T plus angle double prime. So this is this is what one of our answers would look like. Equal to. So we'll get two separate sinusoidal functions, and then we would add them, just like how we would add our voltages or current from other problems. So here in this circuit, we have a inductor, a capacitor, and a resistor. So before we start solving, let's convert these devices into their impedance form. So, and remember to calculate the impedance for a capacitor, it's going to be negative 1 over W J. Not J, C. Negative 1 over WC for capacitor, and for a inductor, it's going to be WC or WL. And these will have the imaginary starting, so be J of J. So with that in mind, let's calculate the impedance for this capacitor right here. So it'll be negative 1 over, and then let's actually choose, we have to choose a voltage source to start out with. We'll start out with this one right here. And remember, when we're shutting down a voltage source, we turn it into a wire. So let's copy that right there and turn this into a wire. Okay, so now we are using the VA sinusoidal voltage source, and we'll see that our W is 200. So getting the impedance for the capacitor is going to be 200 times 200 microfarads times 10 to the negative 6. So doing that in our calculator, and when we do that, we get negative J25 ohms. Because remember, the unit for impedance is in ohms. Now we'll do the impedance for the inductor, which is going to be 250 times 10 to the negative 3 times 200. And when we do that in our calculator, times 10 to the negative 3 times 200, we get 50, so it'll be J 50 ohms. And then for a resistor, the impedance is simply equal to the resistance, 50. So we can replace our, or redraw our circuit with those in mind. So we'll just replace these values with the values we found, just so that it's more simple for us. Negative J, 25. And then we can also just replace these with resistors. And then put the value that we found. Oops. J, 50, and 50 right here. So what we're trying to do, solve for, is solve for the voltage across right here. So if we look at our circuit right here, one thing that we can see is that these two resistors right here are actually in parallel, and since we're trying to find the voltage right here, the voltage at this node right here will be the same for both of these impedances. So we can just calculate those in parallel, which will be equal to, this will be equal to negative 50, 50J. So we can rewrite our circuit, or repaste our circuit in here, and just keep this, write the value we just found, and this is our new circuit. So now, looking at our new circuit, we can see that this is actually a voltage divider. So we can use the voltage divider equation, which is as follows. V out equals R, in this case, we can just use Z2 over Z1 plus Z2 times voltage in. So, plugging everything in, and before we plug stuff in, we are going to write our VA in polar form. So, to write it in polar form, it's just going to be 140 and 135. So it has 140 with an angle of 135. 135 degrees. Okay, so now we can plug everything in. So our Z2 is going to be negative J50 over 50 minus, because there's a negative here, and we're adding, so it's just, we'll just put the negative in there, 50 times 140. Actually, let's put this in rectangular form, because it'll be much simpler for us to put this in our calculator. So to get rectangular form, so to get the real value, it's going to be cosine. So we're going to do 140 cosine 135, and that's going to give us our real value of negative 98 point, actually we'll round that to negative 99. And to get our imaginary value, it's going to be 140 sine 135, which will be plus J99. So now we will plug that in right here and multiply this by negative 99 plus J99. And I'm going to just move this down here so that we can have more room. And then we will simply plug this into our calculator. So we get a value of 90 or J99. So now what we're going to want to do is we're going to want to convert this into polar form. Now if you have a TI-84 plus CE, you can do this really easily by taking the answer that you got, your 99I, which if you haven't noticed, there's no J on the calculator, so you just use I. So if you take your 99I, and then you go to Math, Complex, and then all the way down to number 7, which is polar, it'll convert it into a form that looks like this, 99 E 90I. Now this is Euler's formula, and it's really helpful here because our calculator really likes using this. So right here we have our amplitude. So it's going to be 99 cosine, and then we will use the same frequency from above, or W, which was 200 T plus, and then right here, this is our amplitude, and this will be, this right here is our angle. So plus 90 degrees. And that is our answer for VA. So we'll just put V with VA as a subscript. So that's our answer for this one. Okay, now we will solve for the other voltage source, or sinusoidal voltage source. So we will turn this into a wire, and then we will now have to calculate our impedances again, because this source has a different angular frequency. It has a different angular frequency. So to make things easier for me, I'm just going to copy this and put it down here. And that is our sinusoidal voltage source. So to start, we will calculate the impedance for each of our devices. So for the capacitor, it's going to be negative J 1 over 100 times 200 times 10 to the power of negative 6. And if we plug that into our calculator, we get negative 50J. Negative 50J. And for the inductor, we will get 250 times 10 to the power of negative 3 times 100. Plug that into our calculator, times 100, and we get J25. And then for our resistor, it's just, again, simply the exact same value in ohms. Remember, these are all, impedance is all in ohms. Okay? So now, we see that if we look at our circuit right here, we see that our resistor and our inductor are actually in parallel. So what we can do is just put them, or do a parallel combination to combine those two devices. So it'll be something like this. J25 in parallel with 50, and that'll be equal to we get 10 plus 20 j, 20j. So let's quickly just redraw our circuit. And with 10 plus j, 20, and then this as our capacitor, which was negative j, 50. And remember, we are trying to get this voltage right here, and this is again a voltage divider. So we can use our voltage divider equation that we used up here, right here. Again, we can use it again. So we will first, actually, let's take our voltage sinusoidal function right here and convert it into rectangular form. So to do that, we'll do the same method we did above, be 70 cosine 45 to get, let's do it right here, VB is equal to 40, actually we'll just round that to 49.5, an angle of 45. Actually, no, we're doing rectangular form. And then it'd be 70 sine 45, which is the exact same. 49.5, but imaginary. Okay, so now we'll do our voltage divider, which is going to be 10 plus j 20 over 10 plus j 20 minus j 50. Now we can simplify this to just 10 plus j 20 over 10 plus or minus j 30. And then we'll multiply that by 49.5 plus j 49.5. And as a quick suggestion is when using imaginary numbers in your calculator, you want to make sure that you are using parentheses, because I've run into issues where I'm not using parentheses and just the multiplication sign, and you end up with the wrong answer. So when we do this calculation, we end up with a real value. So the naught would be negative 49.5 cosine 100 t. And then we can do the same thing we did before from our calculator, convert it to polar form, and we get a angle of 0 plus 0, or 180, the same thing. And that is our answer. So to show that, we can simply show that V naught is equal to this value right here. We'll just copy that, copy this value plus, or in this case, yeah, we'll put plus, no, in this case, minus 49.5 cosine 100t plus 0 degrees. And this right here is our final answer.